Hello everyone, welcome to SUJI'S physics classroom. Today we will be discussing about dimensional analysis. So in this video we will discuss about dimensions, dimensional formulae, dimensional equations and a few examples. So dimensions of a physical quantity. In the previous chapters we have discussed that physical quantities are being classified into two, that is fundamental and derived physical quantities. So, the dimensions of a physical quantity are the powers or exponents to which the base quantities are raised to represent the given physical quantity. You will understand more when we take few examples. So, before that, we need to know a quick recap on 7 fundamental units. These are length, mass, time, temperature, electric current, luminous intensity and amount of substance, their respective units and their symbols you can see in the second and third column. There are 7 fundamental or base quantities. So, I have already told that derived physical quantities can be expressed in terms of fundamental, some combination of fundamental physical quantities, but in a different way we are going to express these. That is, inside the square bracket, we will denote the 7 fundamental physical quantities. So we call them as dimensions. So there are 7 dimensions for length, mass, time, electric current, temperature, then luminous intensity and amount of substance. So length is represented how it is represented like capital letter L inside the square bracket, then mass m, time t, then electric current, temperature and luminous intensity has been represented by their respective unit like ampere, Kelvin, centella and mole inside the square bracket. The first 3 has been represented by their first letters, capital letter, length, mass and time, L, M and T inside the square bracket. Now in mechanics, all the physical quantities can be written in terms of dimensions, especially in terms of length, mass and time. So a few examples we will just take. First one is area. So area, everybody knows area is length into breadth. So length is a distance, so we can represent it with L, breadth, L, distance only, right? So L into L is L square, but when we write in terms of dimensional formulae, it will be inside a square bracket, L into L. Inside the square bracket, we will write L square. And same way, volume is length into breadth into height. So it is these 3 represents a distance, means distances, right? So L into L into L, it's L cube. So some more examples we'll have for velocity, displacement by time. Displacement again, it's a length. So L divided by T, but in terms of dimensional formulae, the method is inside to write inside the square bracket. Okay, so it will be like L divided by T. They won't keep anything in the denominator. It has to be taken up on the numerator side. So it will be like LT raised to minus 1. Same way, acceleration is velocity divided by time. So velocity we already know LT raised to minus 1. So for velocity you can substitute that LT raised to minus 1 and time is T. So I told you nothing should be there on the denominator. So LT raised to minus 1 into T raised to minus 1, right? So what is that T raised to minus 1 into T raised to minus 1 is? T raised to minus 1 plus minus 1 is T raised to minus 2. So it will be LT raised to minus 2. Next is force. You know, force is mass into acceleration. So mass is m and acceleration is LT raised to minus 2. So it has to be written inside the square bracket. So mLT raised to minus 2. Next is density, mass by volume, that is m divided by L cube, mL raised to minus 3. So all these are called as dimensional formulae. So these expressions are called as dimensional formulae. So what are the dimensional formula? In dimensional formula, we express how many times or which all physical quantities comes in the derived physical which all fundamental physical quantities comes, isn't it? How many times it comes, it represent the derived physical quantities. So we can say that dimension formula is the expression which shows how and which of the fundamental quantities represent the given physical quantity. So these expressions are called as dimensional formula. For example, for volume, we know it's L cube, but in terms of ml and t, we will represent m raised to 0. There is no mass term comes when we measure volume. We need not measure mass. Time is also not required. Only it is length into breadth into height. So L cube. Same way, dimension formula for velocity, mass terms is 0. Length is there, L, t raised to minus 1. So, in same way, force is m, L, t raised to minus 2. Mass into acceleration, no? So, mass comes one time, L comes one time, but we don't write 1. If it is not coming, we need to represent it with the letter 0. So, a raised to 0 is 1, right? So, it doesn't affect. So, that's why. So, m, L, t raised to minus. Here you can't write m0. Here m comes. Mass into acceleration is force. So, m, L, t raised to minus 2. So, these are called dimensional formulas. These expressions, which is written inside the square bracket in terms of ml and t, is called as dimensional formulas. It doesn't mean that it comes only with ml and t. When we take the expressions or the dimension formula for electric charge, potential and all, time, current and all, it comes there. Okay, so ampere also comes there. Okay, but in this mechanics mainly, we will take these three, m, l and t. Okay, now next is dimensional equations. So, dimensional formula, we have understood these are the expressions. But when we equate this dimensional formula or the expression with the given physical quantity, it becomes an equation, right? So, that is called as dimensional equations. So, a dimensional equation is obtained when a physical quantity is equated with what? Dimensional formula. So, here velocity inside the square bracket v is getting equated with the dimensional formula of velocity m, L, t raised to m raised to 0, L, t raised to minus 1. So, m factor 0 there. Same way, dimension formula for acceleration is inside the square bracket, we will write a equal to inside the square bracket m raised to 0, L, t raised to minus 2. Or in this way also you can represent. Inside the square bracket you can write acceleration. Now, dimension formula for, equation for forces, F is equal to ml t raised to minus 2. Okay, so for your more practice, there are a few questions like momentum, work, power, kinetic energy, relative density, and electric charge. And you can watch our next video for solving more practice questions, including this. This is easy. You can just try. We know momentum P is equal to m into v. Work is equal to what? Force into displacement, and power is work by time. Kinetic energy is half mv